Hello, I'm Nobby. Welcome to my workshop. I'm going to carry on with machining parts for the PM Research engine. The bit I'm going to attempt next is the Eccentric. They call it the Eccentric hub, which is this part here. And this controls the movement of the piston valve. The piece of material they give you is this piece of steel of some kind. The outside measurement shown on the drawing here is 0.624. Now I've measured this with my digital vernier, and it is 624, so it is already at the correct diameter. So there's nothing really to machine on the outside at all, apart from possibly just cleaning it up, make it look a little bit shinier. This part, the Eccentric, takes this, which they also call the Eccentric. This part will run on the outside here, so it's running on this outside diameter. So it's this part that will need the inside machining, so that it's a good fit, not a really tight fit, because this has to have some movement to it. So you obviously don't want that to jam. You don't want it to be loose or too tight. Now the offset, they give us 100 thousandths. So this has got to be set up in the lathe, obviously faced off, and then you need to from the centre here measure an offset of 100 thousandths, so that you can then adjust this either, well, probably in a 4-jaw chuck, to give you that offset, and then machine this here. It doesn't seem to give you a diameter for this part, but the drawing here seems to be to scale, so I'm reckoning that needs to be 1/2 inch diameter, although I don't think that diameter there is that critical. The critical one obviously is the outside diameter, because that's going to control the throw of the piston valve. So looking at it as a side view, you have this offset here, and that's again the outside diameter, and in here there's a groove. Now there's another part that fits into this ring that goes into here as a rod, which connects this to the piston valve, and the rod is designed to go right the way through here and ride into this groove, and it gives you a diameter for this as well to be cut, and a depth as well. So on the face of it, I guess not too difficult a part to machine really, but obviously you can't take anything for granted on any part of this engine. Everything really needs to be machined as accurate as you possibly can. So my reasoning for doing this part next is that this part will sit inside here, and the reason I'm machining that part first is that on some of the images I've seen of this engine before, these inner faces here have been machined, because you see that they've got a sort of a taper draft in these. But when I measured the diameter across here, it seemed that there is enough room for the Eccentric to ride in here, providing it's locked centrally in place. But what I want to do is machine the part up and put it on the spindle which runs through here to make sure that it has got sufficient clearance on each side. If it hasn't, then of course I can then machine these faces here, but it may not be necessary to do that because all the parts, the flywheel on this side and the cam on this side, are all locked onto the shaft, so it should be able to arrange it so that that part is held exactly in the centre. But that was sort of my reasoning for doing that part next. Something I forgot to mention, most important actually, that when this is set up on the lathe to machine this the outside of this offset here, is that you need to drill and ream this to 1/4 of an inch. That's the diameter of the shaft which carries the flywheel and everything else. So that needs to be done as well. But obviously that's very important, but I seem to have skipped that part when I mentioned the other machining operations. And the other thing is that there's also a tapped hole here, which is also shown here, which locks this part onto the shaft. In the drawings, this gives it a measurement for an American standard screw, if you like, but I'm replacing a lot of the screws using this for if you like, sort of English standard screws, so that this will actually be drilled and tapped for a 5BA grub screw. And I'll be using 5BA machine head screws for a lot of the fittings on this throughout. Just thought I'd mention that part as well. Okay, well the first thing, as always, is to face off the end of the part here. That's faced off nicely. These parts seem to be cut very accurately. It only needed a very slight bit. I don't know what the material is that they give you here. It's obviously just listed as being steel, but it does machine really beautifully as well. Now what I want to do next is not to put a centre right into the part here. Obviously where you faced it off you can see where the dead centre is, but I want to just mark it just very, very slightly to give me a data point in the centre, so that I've got a means of sort of accurately measuring off the 100,000th offset to one side. So I'm just going to bring a centering tool in very, very gently, just to put a tiny little mark in the centre there. I think that's all it needs. I'm hoping this is going to be a good way of doing it, but that gives me a little data point in the centre there. Right, but the way I've worked out my offset is probably different to the way everyone else or anyone else would have done it, and I hope this is going to be an accurate way of doing it, although I am going to measure this up separately just to make sure the measurements are correct. So what I did previously, I obviously faced the end off and I put a tiny little pot mark in the centre here as a data point, so then I need the offset here to 100/1000 of an inch. So what I've done, I've put, this is actually a chamfering tool, but it does have a very, very sharp point. So I very, very carefully lined that up with the mark in the centre here, and then I use this tool running the cross slide across to put a scratch line across here. I locked the chuck in position so it couldn't move while I was doing this, and then I ran the cross slide back and then very, very carefully brought it across here to line up with that pot mark in the centre, and then used the micrometer scale on the top slide to wind that across 100/1000, and then I brought the point against the work here and then made a little scratch mark here as well, so that in theory that should give me my 100/1000 offset. So what I can do, obviously I'm going to check this off camera to make sure that is an accurate measurement. I can put a little pot mark in here, and then I can use that mark to set this up in a 4-jaw chuck so that I can then machine the offset here, and of course drill the 1/4 inch reamed hole. I hope that makes sense. It does to me at the moment, but we'll just see how well this has worked out when I take some measurements on this in a bit. Obviously I'll bring you back and explain, whether that's worked or not, and whether it was a good way to do it or not. You probably think this is a peculiar way of actually testing my marking out here, but I could have actually marked this out this way in the first place, taking it that the diameter of the material here is 624 thousandths, so the centre here is 312 thousandths. So if I take off from that the offset 100 thousandths, that gives me 212. So what I've done, I've set the height gauge here 212 up from the surface here, and then use the very sort of edge of the scriber here to check that I've got that little mark in exactly the right place. Of course I could have set it up just in marking that line here, making sure that this is aligned this way perfectly, which wouldn't have been that easy to do, I guess, and then just scribing the line across. But I think by doing it in the lathe chuck, well, either way it seems to have worked out okay. So I know now that I've got that mark here at the correct position. So what I can do now, I can just sort of centre pop that and set this up now in a 4-jaw chuck in the usual method of lining up that position, and then I can machine that and obviously drill it for the reamed hole as well. Rather a cockeyed way of doing it, but in the end it worked out okay. So I've done it on the lathe and tested it this way as well, and it's worked out fine. I've got the workpiece set up in the forward jaw chuck now, with the live centre and a dead centre between that and the workpiece, so that's set up in the offset position there, and I've got my clock gauge on it, and as best as I can get this is to within about 1 thou, which I think is going to be okay. I think there's a bit of bounce here. It may be the surface here. I think I've moved the gauge backwards and forwards, but it seems to be about the same, so about 1 thou. I think that's going to be okay. So I can break this down now, and the first job I'm going to do is drill the quarter-inch reamer. So that'll be the next job. Well, first we'll go in with the centre drill. I'm drilling with a slightly smaller drill first, slightly under the drill size for the reamer. This is a 15/64 drill, which is just under the quarter size. I'm going in fairly deep, just a fraction over 1/2 inch, because obviously the reamer is going to be going into a blind hole as well, so make sure I've got enough clearance here. Now I've got set up with the reamer. Well, now we're going with the reamer. Plenty of lubrication on that. I'm running the lathe obviously very much slower now. That's down to sort of bottom of the hole now. That's it. That should be fine. So that's that part of the operation. So certainly looks okay. So then the next job now, I'll need to machine now the offset part around here. I've just got to measure out the depth of that. That looks okay. Right, so I'll bring you back for a bit of that as well. I've just blown the swarf out from the hole there. This is the shaft that this will fit onto, as well as the flywheel and the cam, and that's fit. Obviously it's going to push itself out under the pressure, but that's a really nice fit into there, so that's good. Well, the next bit is machining the offset part here. The overall dimension of this part in sort of total width, if you like, is 7/16, and the little step here is 3/16, which is 0.1875 thou. So I've marked up here in a few positions the if you like, the depth of that part. So this is obviously going to be an interrupted cut, because there's obviously more on this side to come out, and I'm machining it down from the drawing. It looks like I machine it down till I touch the part here, which is the sort of wall, the overall wall thickness of the hole to the edge here, and I think you end up with the part being about 1/2 inch in diameter. But when I machined it down roughly to here, I can then sort of make some measurements on it. So I'll show a little bit of this, but obviously it's something I've got to concentrate very carefully on doing. So I'm going to bring the tool across just to mark this position so that I can see exactly where I'm machining to. Obviously, in terms of depth, if I overshoot that, it's not too serious, because I could then face this off to the correct depth afterwards if need be. But we'll see how we get on. I'll do the rest of this off camera and bring you back when I'm sort of nearer to size. Well, referring to the drawing, it doesn't actually state the diameter of this part. So it's a bit of guesswork here. I'm at the correct depth this way, which is 0.1875, so that's correct. But if you sort of run that round, you'll see that it's not taken that part out here. But looking at the drawing, the grub screw, it would be drilled in from, that's the part you can see in blue there. The grub screw goes in from this side, and looking at the drawing, it's allowing you a greater wall thickness on this side than that side. I assume that's so you've got a better thread engagement through here. So that's, you know, it's slightly off balance, if you like, but then the whole thing is off balance actually. So I'm going to leave it at that. The last job on here basically is just to put a chamfer on the edge here to get that sharp edge off, and then it will be there's no machining required here because we're already at the right overall diameter, but it's obviously got to be cut off to the correct length here, but then there's got to be a slot machining into that side as well, which I shall do that next. I'll put this back into a 3-jaw chuck so that I can put that slot into the position. So it's just changed the tool over for chamfering tool, and we'll put a nice chamfer on the edge there, so you've got no sharp edge to it. So that's slightly better angle. You can bring that in. So that's it, that bit's finished. I've just got to sort of clean around here. I'll do that in a moment, but that's it basically. So I can bring you back perhaps for the next part of this when I get set up to machine the basically the slot, and then cutting the part off to length. Right, well, the next job is cutting the slot in here. This section overall is going to be 1/4 of an inch wide, 0.250, and the slot in here is 100 thousandths wide. So I've measured all this out. So the slot here I'm going to cut with it's a very, very narrow parting tool. This is 0.060 wide, so obviously I'll have to make sort of 2 plunges into here to cut that. So I think what I'll probably do first is plunge into the centre and then bring the edges to size. I'll show a little bit of this, but obviously I've really got to concentrate on doing this to get it right. The depth it's got to go in is 0.075, so that it will give it an internal diameter of 0.475 internal diameter. That's obviously just to give a clearance for the screw that will sort of locate into that. So I'm guessing that the depth that may not be incredibly crucial, and this obviously is acting as a guide for that screw to keep it centered within that part. So let's get on with it. Okay, well I reckon that is correct for depth. I'm using the micrometer dial on the cross slide to give me that measurement. So the rest of it I'm going to do off camera because that's obviously is much more critical. But I'll bring you back when that part's completed. All right, well that part's done. I've machined, as I mentioned, the centre part first, and then brought the cutter across to each side, and I've plunged in there, and I'm within a thou. It's just a thou over, which I reckon's all right. And the width across here should be 100 thousandths. I'm 104, which I guess that's okay. So the only part to do now is actually to part this off. I don't know what this material is, but it machines beautifully. I have no idea what type of steel this is. It doesn't say in the instructions that come with the kit, but it does machine nicely and gives a sort of really beautiful finish as well. So I'm going to get that sort of set up and part this off now. I'll probably use the same tool to do it. Probably no need particularly to show you that part of it, but obviously I'll show you the part when it's completed. But there is still another job to do after this, basically, and I obviously can bring you back for that. Well, apart from drilling and tapping a hole through here for the grub screw, this part's finished. I put this, I've obviously parted it off, and I've faced off the sort of backside here, and I put it back in the chuck the opposite way round, just so that I could run the reamer by hand through here, just to make sure the hole is nice and clean, and the shaft does fit very, very nicely in there. It's a beautiful fit. So let's take that out of the chuck. So that part is done. So we've got our nice eccentric there. Before I completed cutting the groove in there, I did just run some Scotch-Brite around the outside of this, just to just sort of clean it up a bit, just make it look a bit nicer. I'll drill and tap the hole for the grub screw, and I'm really ready to show you that. But the next job is to make this eccentric strap, or whatever you want to call it, I don't know, that's got to fit over here. Quite a dicey thing really, because this is in terms of its outside diameter it's correct, and the width across here is correct. What I've got to do is mount this into the chuck, and then use a boring bar on the inside to fit this in. So that's obviously got to be very, very carefully done. And then there's got to be a hole drilled and tapped in here. I think I'm using 7BA for that size. So the little shaft with the 7BA thread will go right the way through that and locate into this slot here. So that's the next job along to do. I may not film that part because I don't want to make this section of the video too long, actually. So that's the next bit, but that's before we start the next job along. I can bring you back and sort of show you this, but what I will do is just try this in the base and see if I do have enough clearance in this. Bear me just a second, I'll see if I can do that now. Well, it does look on inspection that this is where this part will live. Actually, the other way around, I think, but that doesn't matter. So that will obviously revolve in here. That should be the other way around, of course. This bit should be over that side. But turning that round, it is clearing the walls on each side there. So if that's locked carefully in place, or everything is locked carefully in place, I don't think I've got to worry about machining these inside faces, which I'm quite pleased not to have to do that. So that looks as though that will be okay. So no worries there at all. Well, I think in terms of this little episode, I think I will draw this bit to a close. I'll just carry on and machine that little brass ring to fit round there. I'll do that bit next. So there we are. So looking forward to seeing you in the next part. Bye for now. Well, hopefully you're still with me for a bit. I just wanted to show you what stage I'm at the moment. In the last bit I showed making the little eccentric here. So that's all completed. That was, quite an interesting part to make and came out quite nicely. What I've also done is I've drilled and tapped a hole here for a grub screw, which will be a locking screw to lock it onto the shaft here. Once you've got it set for the correct position, I'll need to shorten the grub screw a bit, because I bought these 5BA grub screws and they only had them in 1/4 inch long, which is too long, so I need just to shorten that slightly. The other thing I had to do was to machine the other part of the eccentric to size to fit onto here. It just means making a few very light passes on the inside here with a boring bar to get that to the right size, so that will slide inside. If I can get that in straight, that's it. So it needs to be a nice fit, but not too loose or too tight. This obviously has to be able to, the inner part of the eccentric needs to be able to revolve inside here nicely. And also I needed to drill and tap a little hole here and put a flat on the top as well. This is drilled and tapped to 7BA. I'm not using the fixtures provided with the kit. I wanted to use, if you like, British standard screws throughout on the model, and not use the ones provided. So what fits into here is this rod. This will connect the brass part of the eccentric to the piston valve. So that will screw into here. I didn't show any of this. This part was actually very, very simple to do. They provide you with this brass rod, and it was just a matter of threading each end with 7BA thread. So that would screw into here and would screw through, so that the inner part of the thread would engage in this slot that was machined into the eccentric, and that would obviously hold that in the correct position. The other ends would attach to the piston rod. Also, the plans indicate sort of making the nuts for this yourself. interesting thing to make, that they provide you with some hex bar, brass hex bar stock to make them out of. Those are quite interesting because they are obviously a very, very small part. In all, I had to make 4 little nuts, 2 for this one, one additional one with the same thread size, 7BA. That's for one end of the piston rod, and I had to make a 4th one with a 5BA thread on it for the other end of the piston rod. These are to sort of hold the piston rod onto the piston itself. Fiddly parts to make, but here's a little production line running to make these, so it was quite a nice thing to make those. What I'm going to do, I'm just going to sort of assemble these parts onto the base so you can see what they actually look like in position. So bear with me just for a moment. Well, that's what they look like assembled. So you've got the eccentric in here, and obviously once you set the correct distance on this rod to the piston valve, that can, when you've got the right position, the eccentric can be then locked in place with a little grub screw. The rod will require a couple of bends in it because the piston valve sort of ends up sort of about here somewhere, so that will be sort of bent across and around to join in, and the thread here gives you the adjustment you need on the end of the piston valve, and then the little nut there is designed to sort of lock it in position, the same as it is here. So that's why you've got the little flat on the brass part of the eccentric to sort of lock that in place. So in the end, that sort of actually turned out quite nicely, actually. So you've got the flywheel here and the little cam on that side. The shaft here obviously can be adjusted for length, but I'm just going to leave it as it is for the moment until everything is assembled, and I might leave it a little bit longer on this end, because what you could obviously do is make up another little pulley on the end here if you wanted to use the engine to run some other accessory as well. So I'm sorry I didn't bother to sort of show the machining of these bits, but to be honest, there is so many parts to machine in this little kit that I know I can't show every part being made, because it would just make the little series I'm doing too long, really. So some sort of these sort of simple, easy parts, I'll just do a few of these bits off camera, but try and show you perhaps the most interesting parts of it. One sort of question for you, actually. There are a number of positions on this that have sort of oiling ports. There are 2 oiling ports here to oil the shaft. And let me just grab the other part, if I can find it. And where you've got the little crosshead covers, which will sit sort of either side here, there's a point here which you can drill through for an oiling port as well. But of course it occurred to me that as the eccentric is running inside this brass ring, there's no oiling port here. It doesn't indicate that there should be one in the drawings at all, but I just wondered whether you think a little hole should be drilled through here as well, so you can drop some oil into here. And then obviously you can just sort of feed some oil through the side here, just sort of tip the engine on one side and feed some oil through. Equally, you could do that with the shaft here as well, although that is quite a close fit. But I don't know what you think, whether that would be. I've seen this on much larger engines where they've got proper little oilers that fit into these positions, and sometimes on the Eccentric they've got a little oiler, because this part doesn't move round. It stays in this position. It's only the internal part of the Eccentric that moves round. So I don't know what you think. If you think that's something I should do, let me know through the comments there. There are no oilers to be made in the kit to fit in here, but I do notice on some of other images of this engine I've seen, there are little oilers that have been made to pop into these all these positions, in here, and on top of the little crosshead caps as well. So I might I might make some of those anyway. They're going to be tiny little things to make, but that would be sort of another little challenge to make some of those as well. Let me know what you think. Anyway, well, that's it. So that is the end of this little episode, and hope to bring you back for another part of this build very soon. Thanks very much. Bye for now.